we usually need to plug the wax.
Yeah, the metal, just getting through the metal. He's trying to cylinder reverse, so instead of keeping it back, I tried to do it the other way where it stays down and then when it's next something that doesn't, but you know, if both go, you spin it will stay down, but if one does, it. I just tried to come up with some
Yeah, I would. This stuff, it's in the book doesn't read it really anything.
I feel like it's kind of just like that's right out throughout the chapter.
Yeah.
When I was studying last night, I would see stuff for analog and I was looking at
things
I
up.
feel like I just feel like I said kind of here and there.
Yep, they toss it in like the first chapter and second chapter.
Yeah, and random different like paragraphs talking about it.
That's where,
It's not very well organized.
when it transmits.
Let's talk about this analog. So Siemens analog, let me open up this document here.
The O is 0.
So on our PLC trainers, let's take a look at them. Here are the specs on the analog inputs.
Should we write this down?
No, this is more for your, I would take some notes because you're gonna need the information when you set up your program or whatever. So the analog inputs, there are, actually, look at your trainer and flip down that top door on there. Let's take a look at the hardware first. If you look to the far right on the top door, there's 3 terminals. Those are your analog inputs right here. 2 channels, channel 0, channel 1. This M, it is ground connection. M is a German, it's an abbreviation for a German word. Masse, something, I don't know. I looked it up a while back, I couldn't pronounce it, so I said forget it. There you go. You might have seen it in some documentation, I'm sure. But whatever it is.
Fancy.
So that M, that's where that M comes from. And if you look on the trainers, N means ground connection. It's the DC common on the trainer. Just so you're aware. So we have two analog input channels, and looking at the specs, did everybody find those channels, those analog inputs? We're only using one on the trainer. What's our analog input device on these? Take a look. Take a look at your trainer. Yeah, it's a potentiometer. So the analog input device is the potentiometer on these. Like I say, we're only using one channel. We really need to use both of them, but 2 channels, 0 to 10 volts, bipolar or unipolar?
Unipolar.
Yes. And you remember the magic number in Allen Bradley? 3270?
Yeah, 6270.
Yeah.
67.
67. This is the magic number in Siemens, 27648. All of their analog I/O modules, that's what they're spec'd out to be.
Do we gotta memorize that magic number just like the other one?
I'd write it down.
Okay.
You're gonna need it. You don't have to memorize it. See the resolution, 10 bits, and you would think, okay, if let me do this, and this 27648 has no rhyme or reason. But let me just give you an idea here.
It's not a bulk hole or something?
Right, it's kind of a funky deal. I'm just gonna open up the integer data file in RS Logic 500 real quick. And I'm gonna plug in that number 27648. There's the number. And I'm gonna change the radix to binary. And you see, there's no rhyme or reason for it. But what they've done, I used to have the layout of the bits and everything. What they've done, they're not using any of these lower bits in their analog stuff, that's used for internal stuff. And they're only using like the upper, I don't know, 10 bits. It's 11-bit resolution, so whatever, upper 10 or 11 bits then. Yeah. Like I said, I found the layout of this at one time, I don't know what I did with it, I can't have the file anymore. To give you an idea, it makes no sense. Resolution on the analog inputs, 10 bits, and a lot of information you don't need.
What is there?
And then that hardware layout, something I just dumped into this document. This all came out of the S7-1200 system manual. What I did is I grabbed screenshots of the specs and dropped them into this Word document. So there's our analog inputs and the analog output, the signal board that we add into our PLC, and when we configure it, analog output, plus or minus 10, 12-bit resolution, or 0 to 20 milliamps, 11-bit resolution. So there again, the magic number is 27648. Let's see what else we got here. Anyway. And here's documentation out of the system manual again. Analog modules provide input, whatever. But here are the ranges in the Siemens world, plus minus 10, plus minus 5, 0.5, and so on. The values returned are integer values of 0 to 27648.
Question, with the output and input both having the same resolution, does that also mean that the firmware has to be the same?
Not necessarily. And the instructions that we use to scale analog are real close, they work real close to the SCP instructions. To give you an idea. Tell you what, let's go ahead and do this. Go ahead and open up TIA portal and add in the the PLC and that little analog output module. Don't worry about the HMI or that switch. We won't need it just for this. Just open up PIA port and go ahead and configure the PLC and that little analog output signal board. Yeah. 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 Double click it. Well, 14C, DC, DC, DC. First one. It's the 1AG40. It's the 1AG40, guys.
You want to put in a ScaleX switch?
No, don't worry about the HMI or that switch.
The only one?
Why do you use that one, 2x4? Oh,
I know.
Does everybody, yeah, don't worry about that. Is everybody in device view now?
Yep.
You have your PLC, you have your analog button?
Yeah.
How do you do the analog part?
It's in signal boards over here.
I figured out that I was an idiot and was trying to have them on a signal board.
That's fine.
Yeah.
Sure, you're in device view. And then, let's do this. Click on the PLC, not on the board, just click on the PLC up at the top. So you click, and now let's drag up that bottom window. And make sure you're in the General tab and the Properties tab. And tell me, what are the addresses of the analog inputs? You got channel 0 and channel 1.
64, 65, 66, 67.
Channel 0 starts at what?
64.
64. Input, see the address. What's the full address?
IW64.
Yes, IW64. What's that mean? Yes. What bytes are being used by that?
64 and 65.
You remember back in the Slick 500 days, the Micrologics days?
Way back.
How is analog addressed? How's a discrete device addressed?
7.
Bit level, right? How is analog addressed?
Word level?
Word level, yeah. Did everybody make that connection here? Probably not.
The channels aren't showing up on mine.
I'm still static.
Analog is always addressed in word level, right? So if it's addressed in word level, what data type is that?
Or, I mean,
How many bits are in Word?
16.
How many, okay, what data type has 16 bits in Word? Integer. You guys gotta start connecting these points, right? Start connecting the dots. You should be at that point where you're connecting the dots. It's not just, you know, you gotta make A and B connect at some point. Because that's what gets you there, right? As maintenance people, if you just have all this information and you're not connecting the dots, you're never gonna be a good maintenance person. So IW64 is channel 0. Channel 1, what's that?
Do we need to add that?
What's that?
No, so this.
What's the address of channel 1?
IW66.
Yeah, good, IW66. What?
It's the very top.
And now what's the address of the analog output?